We are now recording. All right, so here's our meeting agenda for today. We'll kick things off with a presentation overview of acoustic detector siting, placement, and programming. And then Patrick, our data manager, again, will conduct a walkthrough of our field maps and data collection, followed by a training by Sarah on our Audible Bats project protocol. And we'll make some time. Yeah.
We're actually not seeing the agenda. I think you need to reshare your PowerPoint.
Okay. So sorry. Try this again. Are we seeing it now? Great. Okay, cool. Thank you, Sarah. All right. And yeah, so we'll make time for question and answers after the acoustic detector siting and placement portion of the presentation, and then again after the Audible Bats protocol presentation. So I know we're packing a lot in here today, so I'll just go ahead and get started. And just as a reminder, please mute your microphones during the presentations. And then here's a quick outline of what we're going to cover here today. I'll go through the data collection protocol. We'll go through site selection, detector placement and siting, as well as detector setup and deployment. And then Sarah will finish this section out with a run through of the Pedersen D500X detector operation and settings. Wildlife Acoustics SM4 operation and settings is detailed in our field manual, which I'll be distributing after the training as well. So for those of you who are using SM4s, that will be contained within our field manual to serve as a reference. So I think it's important to remember why we're conducting bat monitoring. We hear about white nose syndrome, which has been absolutely detrimental to bat populations in the United States, as well as wind turbine related fatalities. And as development of wind facilities continues to gain momentum, it's important that we know what's actually happening with bat population status and trends across the continent, but in this case, here in the Pacific Northwest. And so an example of how we assess status and trends is by utilizing the North American Bat Monitoring Program, or NABat, here in the Pacific Northwest. And the North American Bat Monitoring Program was developed primarily in response to threats to bats like white nose syndrome and wind energy development. So due to these increasing threats, there was a need to have a standardized monitoring program across the continent that can provide the data to understand the declines in bat populations, which in turn aids in directing effective conservation decision making. And so NABat uses a variety of survey methods, such as stationary and mobile acoustic monitoring, as well as conducting colony counts at hibernacula and maternity colonies. And today we will be focusing here on stationary acoustic surveys for this training. So the way the NABat sampling design is set is by following GRIT's order, or generalized random tessellation stratified order, which is a probabilistic approach that ensures subsets are spatially balanced and unbiased. So within each of these GRIT's cells or sample units, you can conduct monitoring methods like stationary, mobile acoustics, and colony counts, et cetera, that I previously mentioned. So we'll go ahead and jump right into the protocol here. We're going to go over the main objectives we're trying to accomplish as we conduct these bat acoustic surveys. And just as a reminder, a sample unit or grid cell, I'll refer to them as sample units today, is a 10 by 10 kilometer square cell. And we should keep these objectives in mind as we go through the training today, especially when we talk about site selection and detector deployment. So the objectives being to detect as many species as possible that are expected within the sample unit by targeting habitats that support multiple species and sites that contain as much landscape heterogeneity as possible across the entire sample unit. And we want to conduct surveys where it's practical and effective. And it is important to resurvey the same sample units in order to contribute to this long-term monitoring effort. So the basic protocol is to deploy 4 detectors within a 10 by 10 kilometer sample unit for 1 night total. You will split the sample unit into 4 quadrants and place 1 detector in each quadrant when possible. If it's not possible, just ensure that your detectors are deployed at least 1.5 kilometers from each other. So approximately a mile from each other if you can't fit 1 detector in each quadrant. Just absolutely make sure that you are in the boundaries of your sample unit. This is probably one of the big takeaways from today because it's been an issue in the past, but all land in Oregon, Washington, and Idaho is broken into this 10 by 10 kilometer grid system, like I showed you a couple slides ago. And so if you are outside of the boundary of your targeted sample unit, then you are in another untargeted sample unit. So you need to place the detectors within the targeted sample unit, not outside of it. And so here's just a general sampling schedule, kind of seasonal schedule to that I would recommend following that we've come up with in order to ensure that the more arid sites in the east or in the south of Idaho, for example, have a greater probability of having more water earlier in the season so that you can record bats that are more likely to be moving on the landscape in those environments. So for Oregon and Washington, this takes us on an east to west approach for timing of your surveys, and then for Idaho from south to north. Okay, so we'll move on to talking about actual site selection. So when starting from your office and reviewing sample units for sites to place your detectors, it's important to look for landscapes that have heterogeneity or variability and native vegetation. So capturing this complexity of habitat will increase the probability of documenting bats and many more species of bats. So try to target areas where bats are roosting, commuting, feeding, and drinking. And as I mentioned, generally more habitat diversity equals more species and numbers of those species. So here's just a couple of example photos of where you have, a water source along with roosting structures such as cliffs and trees in the one photo, or forest edge habitat with a water source. So overall, these are ideal looking site locations. And so in contrast, habitat with less diversity, or that is very homogeneous, you can expect fewer species. Yet, if this is all you have within your sample unit, then still set up a detector in these areas, as data from these areas is still invaluable to the project. Because it's good to know, what bat species are also using these areas. We don't want to just be going to locations or areas where we always expect bats to occur. So documenting bat use of these types of monocultures and this open landscape is still really important. It's still getting valuable data. And so here's some terms that you'll hear us using today in regards to site selection. Detection target is the landscape feature of interest to which to record acoustic bat activity, or where bats are going to be localizing. So, water sources like ponds or a forest edge. Physical clutter is the density of obstacles in the flight environment. So this can be vegetation or water surfaces, which create echoes, which is a source of clutter, cliff faces. Clutter affects the quality of calls and can actually mask bat calls and or call characteristics. So it's important to assess clutter and keep the detectors away from clutter. That's something I'll be going through a little bit later in this presentation. And then acoustic clutter. So, unpredictable sources such as non-stationary objects or sound, such as insect noise, wind, power lines, etc. And so when possible, detectors should be placed to monitor bats in a variety of habitats to maximize the diversity of species likely to be detected. So here's a little schematic of a 10 by 10 kilometer sample unit. So you would be placing 4 detectors in this sample unit. And in this example, each detector would be placed such that they sample different habitat features that may occur in each of the quadrants in the sample unit. And I mean, this schematic is showing sort of an ideal situation. You've got a detector placed in this little forested opening, a detector placed along the stream, a detector placed along this pond edge, and then along this road or trail corridor. Obviously acknowledging that not all sample units will have this nice heterogeneity of habitat, but this is sort of an ideal example. But this helps us to reach our objectives of maximizing the number of species that may likely be detected. Some species may be prone to using one habitat feature over another. So by looking for those different types of habitats to place your detectors, you're sort of capturing the larger species selection. So water is a really important detection target, and ideally flat water. Not all water sources are created equal in this regard. Faster water is not going to work quite as well. Flat water sources just make more ideal detection targets, as bats are more likely to come and drink from them. And so while bats might use fast water as a flight corridor, fast water will trigger the detector and create noise files, which in turn will eat up your memory and batteries. So you just want to make sure that, okay, if all you have is a faster moving water source, that you're sampling in a way that doesn't have the mic facing right at that fast moving crashing water. You'd want to set your detector back a little bit from it so that it isn't creating as much noise. And so if looking at a large water source like this one in this example photo, you want to maybe poke around and try and find a smaller water source, like a stream that might be feeding into this type of large water source, because bats will be more dispersed over this large body of water. So you want to be looking for detection targets or site locations where bats will be more localized or more confined to an area, where, okay, maybe they would be commuting over a smaller stream to this large pond. So looking for target areas that create more localization. And so bats will use natural and engineered water sources. So these can make good sites and typically have still open water. And then also man-made environments like sewage ponds, hatcheries, and golf course ponds. These are also good sources of water for bats and where you'll find bats localizing. And then also where water is the limiting factor. They will drink from the smallest water sources like guzzlers and troughs, these cattle troughs, particularly in those a more arid environment. So these can be very productive sites. And so more mesic or water habitats that are typically more forested. You can find good sites in there, but it can sometimes be a little tricky to find good spots for detector placement when the forest is a little bit more dense, has a denser structure. So you want to be looking for forest openings or breaks in the habitat to place your detector. So in this photo, this might look like a really good spot for bat activity, but it's not the best for your actual acoustic monitoring equipment. And, locations like this have a denser canopy cover, or in this case, these rock walls, which create echoes and record just like lower quality calls in the detector. And so in a spot like this, your bat activity, might be up in the canopy. It might look like a great site for mist netting because of the closed canopy and flatter water, but it's not great for acoustic equipment. So in these tight, narrow areas, you might have to do some engineering to clear a path. And I'll point out that it's not okay to just lash the detector to a tree where it would be positioned in a heavily cluttered environment. So keep that in mind. When you have landscapes or sites that look like these example photos, you might want to sort of tie a tree branch back in order to open up the space a little more for the microphone to record higher quality calls. So different age stands can provide a diversity of insects. There's also likely to be more structural diversity in the older stands. And then, of course, edge habitats provide good diversity. So these are all good examples of site locations. And then in these forest shrub steppe ecotones, you may have these dry sort of riverine areas that may not have any water in them, but they can still make for a pretty good travel corridor for bats. And there's often a lot of insect diversity in these types of areas. And then again, edge habitat is good for foraging. And these open areas also provide opportunities to record high quality bat calls that are away from more cluttered environments. And then same here, again, edge habitat, open space, increased insect and bat diversity, which allows for those clear, high quality calls. In these types of open areas, you're getting what we call search phase calls, which is where bats are actually emitting calls as they're scanning and looking for prey. And you might not get those types of calls back in the deep forest quite as much. So you want to look for larger forested openings like these pictured here. These are good examples. And then for some of those higher elevation sites, there can often be less diversity of bats. So, make sure you're looking for water systems and edges and meadows, ideal sites. And then you often see bats flying down roads or stream corridors, using them for commuting or foraging corridors. So those always make good site locations. And then in addition to water in drier forests, also look for roosting habitat like these snags with exfoliating bark or snags that have hollows or crevices. Look for areas that may have more than one good roost site. So the more snags, the better. But if you only have one really good looking snag, then it may still be worth trying to use that as a site location or as a detection target. And then forests with vertical structure and dead or dying wood offer more opportunities for roosting and foraging. So those can be good areas for that activity. And then, when fine tuning your detector placement, look for large hollow trees and large snags where bats could be roosting. Excuse me. They could contain, nursing colonies, or multiple bats may be inhabiting the roost. Might not be great to focus just on one tree. Excuse me. But if this is all you have, then, I would recommend not pointing the detector straight at the roost. So I'd set it up along the edge away from clutter, and target the opening that the snag is creating here. And so also looking for other types of roosting sites, such as caves and other rock features, such as talus slopes, lava flows, and crevices. Bats use all of those features for roosting, especially here on the east side. And then old buildings also serve as great roosting habitat. Bridges also serve as roosting habitat or night roosting. And there's often good bat diversity at sites like this, as they contain both the water source and roosting structure. And so often you'll encounter habitats like these, but like I was saying earlier, don't be discouraged. It might look like there is lower diversity here, but look a little closer. You might be able to find some habitat for roosts, or dry water features, travel corridors, some foraging areas, etc. If anything, there are open areas which will record high quality calls that are away from clutter. And so if there's no suitable bat habitat, just set up the detector somewhere in the sample unit, because 4 sites per sample unit are still needed, and that absence data is still beneficial for the overall project. Okay, now I'll jump into actual detector placement. So detector placement is maybe one of the most important aspects of collecting good quality acoustic data. So we want to restate our goal here, that we want to collect clear, distinguishing calls of expected species in the area. And so I shared this slide earlier, but wanted to restate the definition of clutter and other interference. So you want to avoid placing the detector, or more importantly, the microphone, near things such as vegetation, which will obstruct the call quality. And you want to stay away from busy roads so you can avoid sounds from vehicles. These are all things that may mask bat calls. And as a rule, which I'll repeat later in the presentation, detectors should be placed 10 to 16 feet away from clutter. So, setting the detector off from say like an edge that has overhanging vegetation, you want to make sure it's set 10 to 16 feet away from that source of clutter. And so search phase calls have the most species-specific call characteristics that allow us to have a more confident identification of the calls. So poor quality calls prevent the ability to confidently identify species presence. So garbage in, garbage out. If you're setting your detector in an area that's cluttered, it's not going to actually record good quality calls. We might not actually be able to use that call for species identification. And so here's kind of just an example of what, good detector site placement looks like. You can see the detector set away from the edge. It doesn't have any clutter obstructing it. And so it collects these types of clear search phase calls that are seen in the photo next to it. So you want these nice, clear quality calls from a nice quality detector placement. And then in turn, here's an example where detectors are placed more in clutter. You can see this one's just like up in the branches. You're going to want to set that out in this more open area. You're still targeting this opening in the forest or this edge, but your microphone is actually collecting high quality calls out in the open. In this case too, it looks like this detector and microphone are just set up in this sort of young, I don't know, this shrubbery, obstructing the microphone. And then, so that type of clutter masks the call characteristics that are needed for species ID, and you end up with these sort of grainy, noisy looking cluttered calls that, we maybe can't even use to make a confident species ID. So just remember, at least 3 meters or 10 feet or more away from clutter. And if this just isn't possible, make sure that your mic orientation is oriented towards the most open space of that area. And so it's important to get that detector mic up high enough to avoid water surface echoes. And you can see in this little diagram here how the call shows an echo coming from the bat to the water surface and up to the microphone. It's reverberating off of that water surface to the microphone, and it creates a more degraded signal. And so you want that bat call to be going directly into the microphone here. So getting your microphone up a little higher in this situation will help give better quality calls. So as bats are approaching clutter, they'll actually alter the structure of their echolocation calls so that they can be gathering more information about their environment. And when this happens, call characteristics become less species specific. So again, we're looking for high quality search phase calls, which you will get from orienting the mic to more open space. And so you want to consider placing the detectors where they're less visible from the general public, obviously, to avoid vandalism or theft. And to reiterate again, rule of thumb, detector should be placed at least 3 to 5 meters or 10 to 16 feet in any direction away from sources of clutter or the detection target. And this includes the microphone. So if you're looking horizontally and it looks clear, pay attention to what's immediately near the microphone. For example, you might have some overhanging branches. So just make sure you're looking up to assess your sources of clutter, and make sure that it is absolutely clear. You don't want the detector facing like a rock wall, or maybe the detector location is open, but your microphone is up in some branches. So just make sure you're kind of looking all around. And again, it might not always be possible. You might have to be closer than 3 meters from a source of clutter, but just do the best you can to orient the mic to the most open space. Okay, and then this is just further guidance for placing detectors near known roost sites or suspect roosts at a site. So you would follow this general guidance of 5 to 10 meters for small roosts, and then 15 to 30 meters for large roosts. So getting back from those roost sources. And so, okay, I'll go through a number of example photos here to give you a better idea of what some good sites look like. So for this photo, assuming bats are roosting back in this forested rocky area, you can place the detector mic perpendicular to the water source, or elevate the detector a little bit upslope here. So not in the trees, but kind of utilizing this edge here and this water source and this ravine. So bats will be localizing up this channel. And so with a water source like this one that has some tree line along the far edge, you can place the detector oriented up and away along the tree line and facing the water where bats might be coming in to drink. So, you could have the detector kind of up here along the edge. I'm hoping you all can actually see my mouse pointer.
We can.
Yeah, okay. And then the microphone kind of facing, towards the water source, but not right next to the water source, set up, but still targeting bats that might be flying in along this edge and then into the water source. And that's just another good site photo. And here's a example of good detector placement, showing the detector offset from the water source detection target. Another great example here, set out in the open, using this little pond as the detection target. And then here's some detectors that are targeting small water sources in a more open, arid landscape. Again, bats love these cattle troughs or guzzlers, and so the detector's placed set back from these water sources in order to record those clear, high-quality calls. And then at this site, they did a good job of camouflaging the detector by painting that pole like a beige color, so it just blends in with the landscape. This particular site, I think that the detector was placed a little bit close to this water source. It might be beneficial to place it just slightly up on the hill here. But this was a good site that recorded 8 species from one of the original field seasons in 2016. And so here's an example of a detector targeting a really nice water source, but you'll notice that it looks like the microphone is oriented right into the overhanging branches. So this is a good example of where you should probably try and scooch it down, look for a more open spot, or tie some of the branches back. You want to open that up so that you can actually pick up the bat calls from bats using this great little pond here. And this site looks like they did a good job of protecting against cattle damage. Cows love to come and just like rub against the detector pole, which can cause some damage to your setup. So yeah, in this case, the detector is set away from the edge of the water. And in this photo, the second photo, the detector is placed, it's actually mounted to this rock basket, which can serve as a good way to secure the detector, especially if cows are present. So using what's there. And then at this site, the detector was placed so that it's set back from the vegetation to avoid insect noise. And the mic is set perpendicular to the travel corridor But in a tighter road corridor like this one, you might need to angle the microphone more to follow the road corridor so that it's not, just pointing directly across this tighter road into the source of clutter that's on the other side. So angling your microphone. And then just a few more good site photos along forest edges. Here, these are good, set away from the forest edge, but still using it as the detection target. And then here's some examples targeting rock features. This detector here, targeting these crevices in this cliff. And then this detector is targeting this more talus-y hillside. Here's an example of a detector that's placed too close to the rock wall. So that will create echoes. You want to set that a little bit further away from that rock wall. And then here's an example from the 2016 Bat Grid original effort. This detector was placed up high where bats are flying through this ravine and foraging near these rocky areas. So this was a great spot that recorded 7 different species. This can be a good site. And then, getting into more cluttered habitat, like what you see on the west side of the mountains, it does become more difficult, but you can, focus your microphone in the direction of the more open corridor in settings like this, in order to capture bats that are, commuting through this corridor. And so this is an example of a trickier site, but do what you can, avoid having the mic right over the water or near the vegetation, target the corridor as bats are moving in and out of this water source. If you're using telescoping poles or have a, pole set where you can elevate it a little higher, you can raise that mic up higher to help get above the clutter at this type of site. And so these are all more cluttered locations, but sometimes this is all you have. So you can always tie some of the vegetation back if that'll help. And just remember to orient that microphone to the more open space. And so just in summary for your detector placement, again, this being so important for collecting good quality calls, place your detectors where bats are commuting, feeding, or drinking. Raise the mic at least 10 feet off the ground, or 3 meters. Point the mic away from sources of bounce or echo, such as rock walls, large bodies of water, and then point the mic away from sources of noise, such as fast water, cars, and vegetation. And so I'll just touch on taking good photos, which is really important. And you can upload these to the field maps data form, which Patrick will run through that data form a little later here. But I'll just run through what we're looking for when it comes to taking photos. So you want to take good photos that encompass the detection target and the detector setup. This helps us determine species ID in some cases. And so to be able to look at habitat and detector location and link it with the call quality data is important to us. So here's a good example. You have detection target is this pond, and then you see your detector setup. You can tell the detector is set away from the edge of the pond. This is a good photo. These are also good photos of deployment and provide us with again, a clear perspective of what the target was and the area in and around the detector. Even with this second photo where it's definitely a little more of a cluttered environment, whoever set this up, they jumped across the stream and got a photo from a different perspective so that we could see exactly what they were targeting with their setup. Another great example of a photo of a detector plus the detection target. And so here we have a photo of just the detector, which can be kind of hard to imagine what the surrounding landscape actually looks like at this site. So, and in some instances, you actually might not be able to capture both the detector and the detection target in one photo. So just take two photos to give us a clearer picture of where the detector was actually placed. So, okay, here's a an example, two examples of supplementary photos that could be taken of the detection targets in addition to a detector photo. Just do your best. And so I'll go over assessing clutter now, which you'll also need to know how to do and enter into the field maps data form. Taking clutter into account is really important, if I haven't made that clear enough, because it helps us with species identification and call quality. Yeah, let me walk through this real quick. So standing at your detector setup, you visually observe and estimate the volume of physical clutter in the entirety of a 50-meter hemispheric space as best as possible. So standing at your detector and looking out over a 50-meter radius and detecting what's around you and what might be cluttering that airspace. So in some cases you might have a hillside that hinders your view. You don't need to go up and see what's on the other side of the hill. Just include that hill in the assessment of clutter. And then be sure to consider all physical objects, vegetation, rocks, human-made structures in your estimation. And then here's a nice little diagram to help you visualize that a little bit better. That 50-meter hemispheric radius with your detector in the middle. And so we've got, 5 different clutter categories here, ranging from 0 to 4. Yeah, remember to look above you. So there will be a clutter type in the data form, which again, we'll go over later. You'll circle the most prominent type of clutter, which most likely is vegetation, but sometimes you have, if it's set up on the hillside, you have the hillside obstructing that 50-meter radius. And okay, I'll show you some example photos of the different categories of clutter. So 0, clutter category 0, there's, no tall vegetation in this photo or anything obstructing that detector setup. Clutter category 1, you've got some taller sagebrush or some rocks, nothing's obstructing the actual microphone, but you have a little bit more structure to the habitat. Clutter category 2, you can see there's some vegetation, getting a little bit taller here. You could maybe set that out a little bit more from that edge. Clutter category 3, again, maybe a little more density to the structure of the forest around this detector setup. And then clutter category 4, 76 to 100%. As you can see, these detectors have quite a bit of vertical vegetation clutter surrounding them. And, I get sometimes this is unavoidable. But again, do your best to orient the microphone well so that it's not totally obscured by the branches. Like it kind of looks like this one is just, that microphone is just up in the tree branches there. So moving it out in a way that allows your microphone to be oriented to that open space is important. Okay, so now I will talk about the equipment that we use here at the Northwest Bat Hub. And I know many of our partners use the same equipment, and then the steps to deploy the detector. So we use Pedersen D500X detectors, and we have a microphone, a mic cable, a mic capsule, which protects the mic well. not in use, batteries, and then a storage box. So how do we set them up? They look kind of like this. We use a painter's pole and pound some rebar into the ground to put the pole on, and then mount the microphone on top of that painter's pole. And here's just a few example photos of some of our setups. So I'm just going to go through these steps pretty quickly on how to deploy the detector and microphone. You want to pound your rebar in with a mallet and then attach the PVC T joining to one end of your pole, and then insert the mic into the capsule. And so the notch of the mic will fit into the hole of this capsule. And then you want to attach the mic cable to the microphone, and then insert the mic into the capsule so that the mic element protrudes from the capsule. So you can see the mic kind of poking out there. And again, that mic capsule is for protection of the microphone during storage and transport, because those are not cheap little objects. And so then you can place your detector in the storage box I would recommend putting the screen against the box wall to prevent damaging the LCD. Ensure that your mic cable is in the notch. We actually put a little notch in the back of the storage box here. And then allow that mic cable to droop below the cable notch to prevent water from intruding along the cable into the box. So, you don't want your cable going upwards where moisture will collect along that microphone cord and then kind of fall into the little notch hole in the back of the storage box and cause water damage. And then, just put your excess cable in the storage box to avoid any damage from rodents that might come along one evening and decide that that looks like something interesting to chew on. And then some folks take additional steps to secure their detectors, like a strap. We actually put a lock on all of our detector boxes when they're out and deployed. You just want to make sure that your cable cord is secured around your pole, your microphone cable cord. We twist ours around the pole like this so that it's not just flapping in the wind and causing excess noise. We kind of gently wrap it around the pole. And then, yeah, don't forget to set your detector to record after you've got it all set up and before you walk away. And oh yeah, and as a reminder, you want to be sure that you're deploying your detector at least 1 hour before local sunset, and leaving the detector set up for one night and retrieving the next morning when possible. And then if it rains for more than half the night, you may want to leave the detector out for a second night. And then just ensure that you're finished deploying detectors at least 1 hour before local sunset time, as a reminder. Okay, so now I'm going to hand this off to Sarah Rose, who's going to be giving a quick run through of operation and settings of Pedersen D500X detectors. And just as a reminder for everyone, all of this information is contained within the field manual, which I will distribute after the training to everyone, along with a recording of this training. So you don't have to have this all memorized. By the end of the training, I won't be quizzing you on the information. So I'm going to stop sharing here and let Sarah hop on to talk about programming the detectors.
Great. Thanks, Beth. Excellent. You seeing my presentation? Cool.
Yes, yeah, looks good.
All right, so I'm going to show you the basic parts of the detector and run through the steps in operating and setting the detector to record. If you have one handy, it might be a good idea to complete the steps as I go through them, especially if you've never handled a Pedersen before. So in addition to your detector, you would need a CF card and 4 C batteries if you were gonna follow along as we go, but it's certainly not required. Before we dive in, I did want to remind everyone that we'll be sending out that updated protocol, which does go over all these steps like Beth mentioned. I recommend keeping a physical copy of the protocol or field manual with you in the field. These are not intuitive devices. It's fairly easy to make mistakes with them, so having that field manual with you can be really helpful. Personally, I've set these things up over 500 times, and just 2 weeks ago, training our field technicians, I had a couple moments where the detector was doing something strange, and I was like, what is this screen it's showing me right now? So even with a lot of practice, they're not, they don't ever become truly 100% foolproof. All right, so first we install the batteries. You open the battery compartment by unscrewing the large screw on the top of the detector and then installing your 4C batteries. We like to use rechargeable batteries. We go through a ton in a season, so it's just a nice way to kind of minimize our environmental footprint. And we have found them to be very reliable, but a lot of folks do use disposable batteries. In regards to putting the batteries in your detector, the springs aren't always quite as springy as we would like. And so sometimes they don't push the batteries all the way to the terminals. So what I like to do is once I've put the batteries in, I make a point to press down on the batteries and slide them away from the springs towards the positive ends of the terminal to make sure that I'm getting a good connection. And another important thing to keep in mind is that the battery tray is only connected to the detector by a little wire harness. So you want to be really careful not to let the battery carriage dangle with the batteries in it. 4C batteries are really heavy, and it's pretty easy to accidentally rip the wires from the circuit board that way. So just make sure that you're being careful with that battery tray as you install or remove your batteries. The next step is to install your CF card or cards. So we were
Uh-oh, I think we might
should
have.
look roughly like this image.
Looks like Sarah is freezing on us.
Oh dear.
Oh, Sarah, there you are. You've been
Yeah.
kind of freezing on us a little bit.
Oh geez. Okay. What was the last thing y'all heard?
Uh, well, you're on the detector
Put in the
operation.
cards,
Yeah.
whatever card or cards.
Okay. I'll just start fresh from putting the cards in just to make sure that we're not missing anything. Sorry about that, guys. My Wi-Fi is usually good at the house, but anyways, so installing the cards, you're going to remove that bottom plate. And then you always want to start with that upper left-hand slot. Then you go lower left, then upper right, then lower right. The order in which you put cards in the detector is numbered in that image. For single night deployments, you want to have at least 32 gigs in the detector. The cards generally come in 16 or 32 gig increments. So we don't usually use more than oh geez. Okay, more than 2 cards per detector. Let's see, oh gosh, my computer's having a little bit of a hissy fit right now. Okay. Okay. Whew. If you have a particularly noisy site that you can't relocate, you may want to put in an extra card because your detector may record a whole lot of noise files and you just want to make sure that you have enough memory to accommodate that. Now there's a little lip on each CF card. When installing, you want to make sure that that lip is facing downward. The cards don't click into place, but they do hold firm, so it should be pretty obvious when they're installed correctly. Then once your cards are installed, you're going to go ahead and flip the power switch to INT for internal power. And your detector should now be waking up. Once it's done, the screen will look something like this. For the first deployment of the season, you're going to want to go through and check all of your settings. I like to do this in the office before I head into the field. That way I can take my time and make sure I do things correctly. The first setting that we want to check is the user profile. We always use user 0. You may have noticed on the last screen that that's what it said at the top. To access the user settings, we're first going to hit F1 to bring us to the ready screen, and then F1 again to bring us to our setting options. Make sure the user profile is highlighted and then press enter. Double check that these settings are correct. If any need to be changed, you press enter and then use the up and down arrows to navigate to the setting that needs to be changed. Use the left and right buttons to change the actual setting. After changing settings on any screen, you have to hit enter to save your changes. So if everything on this screen looks correct, you can go ahead and hit escape to return to the previous screen with your list of setting categories. So from here, we're going to scroll down to recording settings and make sure that we have a gain of 45, a trigger level of 160, and an interval of 0. If all is well, you go ahead and hit escape. And now we're going to go down to timers. This is where things get a little bit less intuitive. Once you select the timers setting, you'll see 4 options. First, select absolute timers. You should see a screen that looks like this. If the first line is just a series of dashes, like the lines below, press the power button to activate a timer 1, then press enter. This will allow you to scroll through the hour and minute lines to set them appropriately. Once finished, press enter to save your changes. Again, if everything looks good, you can just hit escape and return to the previous screen. So we're then going to check our relative timers to make sure that they're off. If our timer 1 shows times as opposed to dashes, simply press the power button to turn that timer off. Don't forget to hit enter afterwards. Next, we're going to scroll down to delayed start and make sure that it reads 0000. If not, simply use the left and right arrows to change it. And then finally, we're going to make sure that auto arm is set to on. Again, we simply use the left and right arrows. Auto arm is a relatively new feature on the Pedersens and helps to avoid some of the more common user errors. Essentially, this setting makes sure that so long as the power switch is set to internal, the detector will start recording at its scheduled start time. This feature was added with a firmware update a few years ago, so if you haven't updated your firmware in a while, you'll want to do that. If you have questions about how to go about that, we can talk about those during the little Q&A session later. But it's a good thing to make sure every season that you are using the most updated firmware that Pedersen recommends for your detector. Okay, we're going to return to our settings menu. If you are on the timer screen, you can hit escape. If you ended up on the ready screen, you hit F1. Scroll down to time settings. Use the left and right arrows to navigate between the time settings and the up and down arrows to change them. Once your detector shows the correct date and time, you can hit enter. You don't need to worry about the zone or the coordinates for this project because we're not using relative timers. That's a whole different system. So once we've hit enter to save our time change, we should be returned to the home screen. You're going to do a quick once over to make sure that everything looks correct. And now is a good time to plug in your microphone to test it. So you plug the microphone into the top of the detector. So it's a 5-pin. You just want to make sure that your pins are lined up correctly. The microphone cable will click into place. You'll hear a distinct click. And once it is plugged in, you can go ahead and make sure that it's detecting sound. So below the word ready, you can see the decibel bar. And if you've got a microphone plugged in and you click your fingernails, snap your fingers, jingle some keys, make any sort of kind of high-pitched noise, you should see that decibel bar filling up as you make sound, and that's how you know that your detector is detecting sound. So setting your detector to record is a very important step. It's luckily pretty simple. From the home screen, you're just going to go ahead and press the record button and then hit enter. It's going to show you the system power down screen, and this is kind of your last check to make sure that everything looks good. So during that little countdown screen, it should say active A timer 1, on 1930, off 6:30, and it'll do this little powering down countdown as it does that, and then the screen's going to go black. And this is just an additional step to check if the detector is set to record. So once the detector's gone to sleep, you can press the power button to momentarily turn on the screen to verify that the unit is ready to record. If recording is working properly, you'll see one of the following messages. So if you're checking it before that 7:30 p.m. start time, the power down screen will say wake up waiting under the start times. And if you're checking it after 7:30 p.m., the power down screen will show wake up armed to let you know that it's actively trying to record. So you want to be very careful when you're shutting down your detector. One of the most common issues that we have is people just opening it up and flipping the switch to off. But this can cause a loss of data. It causes the CF card to become corrupt. So you just want to make sure that you are, when you're going to turn off your detector, you press and hold the on-off button, and then press and hold the on-off button again, hit enter, make sure you're shutting it down that way, and then you can switch the power to off. So I have created a little cheat sheet that can go inside the detector. So what we're doing for our crews this year is providing like a laminated cheat sheet, how to set the detector, what the basic settings are, and how to turn it off correctly. And if anyone wants a copy of that, I can email that to you for you to print out and put in your own detectors, just to try to avoid some of the more common user errors that we encounter. And that's all I've got for that.
Great, thank you, Sarah. Yeah, and we've had a couple of questions in the chat here about types of detectors. Definitely wildlife acoustics, SM4s are great detectors, as are NABat Swifts. Any detector where you can be collecting full spectrum calls, preferably, will be just fine to use. So if there were any more folks out there wondering about, you have a different type of detector, that's totally fine. Preferably shoot for those detectors that record in full spectrum. So yeah, we'll be handing off now to Patrick, who will walk through the field maps. And maybe actually I'll answer just a couple more questions in the chat here. And then we'll move on. Let's see, Paul. Hi, Paul. Since protocol is to place one detector in each of the 4 quadrants in the 10 by 10 kilometer square cell, do all 4 detectors need to record simultaneously the same night, or can you stagger the nights depending on logistical difficulties, access, etc.? Yes, you can place those out on different nights. Yeah, just with the goal of having a detector out for one night in each quadrant at some point. So that's a good question. And then from Kimberly, if you think your card has been corrupted, can you reformat it, or is it no good?
Yeah,
go ahead,
I can
Sarah.
speak to that. So if you think if you have recorded and then you pull your card and you believe it's been corrupted, do not reformat it. We can potentially recover that data. So you don't want to erase all the data off of it. You can reach out to me or Patrick about how to recover the data from a corrupted card. And then it can be fixed after it's been corrupted. So yeah, luckily corruption is a temporary problem. I'm not sure if Patrick has any more insight into that, but we recover data from corrupted cards regularly. It just takes a while. So it's a frustrating, and we don't always get all of the data off of it.
Yes, Sarah, you got it all.
Thanks, guys. Okay, well, let's go ahead and move on. Patrick's going to walk us through field maps, and we'll be sure to circle back to any other questions that are popping up in the chat after his presentation's over. So take it away, Patrick.
Okay, thanks. So now that we've gone over setting up detectors, site selection, and all that, I'm going to review our process for recording all the metadata for these deployments. I know some of you have switched to field maps, but a lot of people still use paper data sheets. We would like to encourage everybody who can to switch to field maps. We've just been able to build in a lot of quality assurance into field maps, so it really reduces our processing and data correction time. And it's pretty straightforward. You don't need a complicated device, just a smartphone or tablet that can connect to Wi-Fi, even if just at the office. Download offline maps and you can use it offline in the field. And if you have any questions getting field maps set up, there's always issues at the start of the season. So just reach out to me and I'll help walk you through any issues you have. So first, is this not progressing? Weird. Okay, sorry. So once you download field maps onto your device, well, before you download field maps, you'll need to make sure you have an ArcGIS Online account and send your ID to me. And so I'll add you to our Arc Online group so you can access the maps. Then once you have field maps downloaded to your device, you'll open it up, you'll log in with that account. And once you are logged into field maps and you've been added to our groups, you'll see your state NABat group that you belong to on that first screen. And within those groups, you'll see an NABat Field Surveys 2023 web map that we'll use for this season. So you'll just select that map and you can explore the map while you're on Wi-Fi. And you can see the different layers we have on there. We have the sample units that everyone is surveying, identifying who is surveying each one. We have a layer that's called site status that are station locations that you will be deploying your detectors at if this sample unit has been used previously. There's a land ownership, or more accurately management layer. It's the protected areas database, and potential campsites if your crews are out camping. These are spots that our crews have stayed at previously. And in that site status layer shows the different survey locations. Most of yours will be these green identified resurvey sites, because I am not going through all of your locations to correct them. Most will just be resurvey unless I've noticed some kind of issue like your location occurring outside of the sample unit. But I may have suggested new sites, which will show up as an orange star. And in that layer, there will be a note that says about what the detection target is and why I moved it. Same for moved sites. Sometimes locations that are poorly performing might be suggested to move if I can identify a good location just from looking at satellite imagery. But most likely, if you see a note on there, it'll be a do not survey site that occurs outside of the sample unit. And I'll try, I think I've contacted most people who have that situation, but I will try to identify new potential survey locations within the cell if you have a location that occurs outside. So since most of these surveys are going to occur where you don't have cell service, we're going to need to download offline maps. So you'll return to the main field maps page and select the more options, 3 dots to the right of the web map, and select add offline area. At the bottom, then you'll see the map, and at the bottom of there, it shows the level of detail, and we usually do neighborhood or streets, plural, level of detail that provides enough coverage area that you can fit multiple sample units in, and includes enough detail for your crews to navigate easily to each site. And then you zoom in to the area you want to download and just hit download area. People have had a little bit of struggles downloading maps sometimes, depending on the amount of storage on your unit or your internet connection. But just try a couple times. If you get failed downloads, if it's a consistent issue, reach out and we can try to figure out if there's a different cause other than the device or internet connection. And you'll need to download an area for each, download a map for each area that you'll be visiting on a hitch. And you'll need to make sure that you include every sample unit you're going to visit, because field maps will not allow you to record data if you're outside of an offline map. So just make sure you have offline maps that have a full coverage of the sample units you're going to visit. And you can also rename them. So if you download multiple maps, you'll go back to the main page, you'll see the offline maps. You can click the 3 dots, the more options, and rename them however you need to help you keep track. So now we'll open an offline, a downloaded map. Just select it in the main page. And you can then review the sample units you're going to survey. So you can scroll in and out of the map, look at the resurvey sites, identify routes to travel to get there. You can select each of these resurvey locations to see the metadata that was recorded previously. Most of them will have a site photo to help you navigate to that exact spot again. And to start, you'll need to make sure that you have navigated to your intended survey location. You're most likely a resurvey spot. And you'll want to make sure your GPS accuracy, which you'll see at the top of the screen, is less than 10 meters. And you'll click the blue plus button in the bottom right corner to collect data. And you need to identify which layer you want to collect data into. So it'll be the survey form 2023. And that'll open up the survey form. First, you'll want to check and make sure your location is accurate. So if you had clicked collect data before your GPS had settled on your location, it'll show your current location separate from the point it just created. If that's the case, wait until the GPS accuracy comes down and click update point. Or if your GPS accuracy was not good enough to start with, you won't have a location. So then wait until that accuracy comes down and you'll hit add point. Just make sure you do not scroll around on the map once you've hit collect data, because that will change the coordinates of where you're recording data for. And as Beth went over, the first step is to take a photo. So you'll just hit the take photo button. Your camera will open up and you'll take a picture that hopefully includes the detector setup and the detection target. And when you're doing this, just take a mental note of the direction that you're taking the photo in. That is a field in the form for later. If you need to take multiple photos, you can do that in field maps as well. And then we'll go through the form and fill out all the fields. There's lots of required fields that are marked as an asterisk, and field maps will not let you submit the form if those are not completed. Lots of our fields are drop downs, so you'll just click the field you want to edit. The list will pop up and you'll select the most appropriate drop down value. If you feel like you need to clarify if the drop downs aren't fully descriptive of what you're experiencing, then use the comments field at the end. And just try to be consistent in how you're filling out the fields that do not have drop downs, so that it's concise and consistent so that we can interpret the hand entered values. This year we've edited it so that when you create a location, the GRITS and CONUS ID fields for the sample units are automatically calculated, so you won't be entering that anymore, but you'll enter the quadrant, the inner cardinal direction of the quad that you're in, and the quad number, which is the site location that you're surveying. So if you're resurveying a green resurvey point, you'll enter the same quad number as that existing point. And if you've moved to a new site, you'll just use the next sequential number from the resurvey site. And then we'll continue with the form, provide navigable directions for the next crew to follow. If you want, you can add a site name to help describe the site. That's optional. You'll enter the deployment date and the recovery date, which are pretty straightforward. And your contact information, your agency, and some land ownership information as well. Then we'll get to the detector information. Please be extra careful when you're entering the detector serial number and the CF or SD cards that you use, because if you mix up labeling your acoustic files once you've pulled them from the detector, as long as this information is correct, we can reassign it appropriately later. And we run lots of data checks later to make sure that the serial number matches the serial number of the acoustic files that you provide as well. And then we'll record the start time and end time of recordings, and that's similar to date. When you first click on it, a calendar shows up, you select the date and then click the clock icon in the top right to enter the time of the start and end of the recording. You'll record the microphone height. It is in meters, and the orientation. And then we have the clutter fields, the photo direction, again, that you noted when you took that photo, and a habitat general descriptor, which is, again, a drop-down list. And then we have all these detection target fields so that as many detection targets as are appropriate to your location, select those. So if you have a water body next to a cliff, you'll have a water body descriptor and a rock feature descriptor. And then there's a comments field. So enter any comments that you think will help us clarify or process the data. If a detector got knocked over in the middle of the night, if it died at some point, if it rained and you need to redeploy it for that or any of the other reasons, make a note there, or just anything else you want to clarify. Then once your form is completed, you'll click the check mark in the top right corner to submit the form. If you are online at the time, so if you're using cellular data, we will receive it instantly. It'll automatically update. If you're offline, you'll need to wait until you get back to the office or somewhere where you have Wi-Fi or cellular data. And on the map page, you'll see that you have made some local edits and you'll need to sync. So you'll click the more options, 3 dots to the right, and sync there. And it'll take a little bit of time. Hopefully it'll say sync complete and not give you an error. But please pay attention to make sure that it did sync successfully. And then once it is synced successfully, it will no longer show any local edits. I would prefer if you double checked with us to make sure that we have received that data, but then you can remove those areas to free up space on your device for your next hitch. And then so for transferring your data to us using field maps, it's very, very fast. As soon as you sync, we have it. Paper data sheets, if you're still doing that for whatever reason, just take photos or scan them and send them to us as soon as possible. For the acoustic data, you'll want to back up your data to a local drive, and then to send it to us, we've been piloting a digital transfer via box and have had pretty good success with folks doing that. So you'll just reach out to me. I'll set up a temporary box folder for you to transfer your data into, and then we can get it much faster and start processing sooner. If you can't do that for agency firewalls or too slow of internet or whatever, you can still send your hard drives or CF cards physically to us. But that's kind of the lowest option in our preference. And then when you're labeling your acoustic data before sending it to us, label it as the sample unit and the site location, and then all your acoustic files should be within those site location directories. And field maps is nice because you can add notes directly to the maps. So if there's any notes you want to add for future crews, future self, you can use markups to make points or line features that are spatial notes. You can type a note in there, and then just make sure you save and share your markup with that NABat group, so that we can access it and add it to future maps. So again, if you have any questions on setting this up, just shoot me an email and I'll get you going.
Thanks, Patrick. Yes, we definitely encourage all of you to, reach out to Patrick and get connected with our Field Maps map. If you have an AGOL account, it just makes for much more streamlined data collection and processing and everything. So we'll go ahead and do a few minutes of questions. So if anyone has questions relating to acoustic sighting, deployment, Pedersen detector programming, or the Field Maps application, feel free to either raise a hand or just unmute yourselves or throw your questions in the chat. We've been having a number of questions in the chat, which Sarah and I have been keeping up with, trying to answer here. I know there was one question, Patrick, about from Brianna, asking about, let's see, there was a note about not adding spaces between entries. Okay, yeah, we're wondering which fields cannot contain spaces. And Sarah was thinking maybe the CF or SD card field, but just, do you have any additional thoughts on that?
Not really. That was kind of an old note.
Oh, okay.
It just, as long as you're consistent, it helps us process it faster. Any of those subjective notes we will review individually, but the CF cards, if it's just a comma in between them, that's easiest, but either way, we'll review most of those subjective fields.
Okay, thanks. Any other folks have questions relating to the acoustic surveys?
Oh, sorry. The spaces definitely does not apply to the notes field. Just write out notes like you normally would.
Yeah. Okay, and Richard, yes, you will want to reach out to Patrick. Patrick, if you want to throw your email in the chat, the most recent firmware version.
So that depends on what serial number your Pedersen has. So to find that, you just go onto Pedersen's website. They have a specific little spot that will tell you which firmware your detector should have based on its serial number.
Great, thanks, Sarah. And as folks, if more questions pop up here over the next 25 or 30 minutes, we'll have another opportunity for more questions at the end. And again, I'll be kind of keeping up with the chat here, but I think we'll just go ahead and move along. So Sarah is going to give a presentation now on the NABat survey protocol. So for those of you who are participating in our NABat surveys, this is all new information that you'll want to stick around for and tune in to. So on to you, Sarah.
Great. Really quickly, start there. I'm gonna do one quick thing. Nope, it's not gonna let me. Okay. This. All right. We see in my intro page. Yep. Okay. Cool. All right. So let's talk audible bats. I'm going to start with a little bit of background and then we'll dive into the protocol. So our two species of interest for this project are spotted and pallid bats. Spotted bats are generally considered a desert-dwelling species, but will occupy dry conifer forests and commute to high elevation meadows. The one habitat feature they seem to specifically require is a sheer cliff face for day roosting. They're highly mobile, solitary as far as we know, and echolocate at around 10 kilohertz, which is considerably lower than most other species in our area and is actually within the range of human hearing. They fly high and are difficult to detect with standard passive acoustic detection settings. Pallid bats are another species that is often considered to be a desert bat, but can be found in some dry forests, agricultural lands, and cool, moist valleys. Pallid bats echolocate at higher frequencies than spotteds and fly lower to the ground, but exhibit two behaviors that make them particularly interesting for this project. They don't rely nearly as much on echolocation for hunting as do other bat species. Instead, they listen for the sounds of terrestrial arthropods moving across the ground to hunt them, so they're very quiet when they're hunting. Additionally, they produce low-frequency directives or social calls that are close to 10 kilohertz, so right around that same mark as spotted bats are echolocating. These social calls, again, are audible to the human ear, and they're actually very distinct from spotted bat echolocation calls. Though pallid bats may produce these calls in a number of situations, calls are likely to be far more consistent near maternity colonies as the mothers communicate with one another and their offspring. Maternity colonies are often found in sheer cliff faces. So I've tried in the past to share these sounds via these meetings. Teams doesn't seem to like to share the sound, but just to give you guys an idea, the spotted bats are producing really simple individual clicks because they're using them for echolocations. It's like tick, 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 tick. The pallid bats are doing little triplicate ticks, so tick, 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 although often you can only hear the first two as they rise in frequency with each tick. So as some of you may be aware, this started out as a small citizen science project looking for spotted bats in Central Oregon. We feel that the public engagement and education aspect is important, and so we are going to continue to conduct citizen science surveys, and we appreciate any help from our partners in spreading the word with the community about that aspect of the project. But the lion's share of the data collection will be done by our field crews and agency partners beginning this year. Rather than reinvent the wheel, we'll be using the NABat framework for survey site selection with a focus on cliff and canyon features. So here's the range map I'm working with for spotted bats for this project. It's from the USGS gap analysis, and it's more based on what we think we know about spotted bat habitat preferences than historic occurrence. So you can see here that there's a pretty big gap in the middle of the supposed spotted bat range, where in the first 5 years of passive acoustics, we didn't detect any spotted bats. Let's see. So we think that because they fly so high and echolocate at such a low frequency and are relatively quiet bats, that we're probably getting a high rate of false negative detection, and that human ears might actually be a better method for monitoring spotted bats, especially in less than ideal habitats, such as places that are have a lot of background noise. And here we have the pallid bat range map, and again, our pallid bat passive acoustic detections for the first 5 years of our NABat work. So a lot of the range maps for pallid bats run up through the Willamette Valley in Oregon, but we have only recorded them in one sample unit during those 5 years. It's been proposed that they've been mostly extirpated from the area. But our focus in regards to pallid bats with this project will be to find out if we can potentially use these surveys to locate maternity colonies, as it seems there hasn't been a big effort to locate those colonies in the Pacific Northwest on like a regional scale. I'm sure a lot of you are aware that we're missing these kinds of hibernacula and large roost locations for many of the species in the Pacific Northwest. It's just something we're probably always going to struggle with around here, but hopefully we can continue to find ways to make it easier to hone in on those sites. And we believe that this method may work well for pallid bats using the listening or oral surveys. So this survey structure is pretty straightforward. Like I mentioned, we're following the NABat framework. So we'll be using those NABat grid cells or sample units to select our survey locations. And then the surveys are pretty simple. So they involve sitting out after sunset and listening for those two species. So again, we're trying to go for replication like we do with NABat. There's going to be a total of 180 minutes of listening per sample unit. We'll go over in a minute how that breaks down, and we'll be using field maps for the data collection. So a lot of this is going to be fairly redundant with the NABat, which is by design. So our surveys begin at the end of civil twilight. Civil twilight is a measurement of the amount of light left on the landscape after the sun sets. So we use a website called timeanddate.com, and we enter a location and then we select a day, and that website will tell us all sorts of information, but the piece that we're looking for is that end of civil twilight. So if you kind of look at this graph here for, what is that, May 1st in whatever location I had this set to, civil twilight ends at 8:40, so that would be our survey start time. Now, as someone who helps to manage field crews, I know that they don't necessarily always make it into the field with all of the information that they need. So our field manual for this project will include this table with rough estimates of the end of civil twilight for each state and for each kind of week or 10-day period throughout our sampling period. So these are rough estimates. I would much rather that people go with the precise civil twilight time, but this is kind of an emergency backup in case techs get out into the field and realize they don't know what time their survey is supposed to start and they have no internet. So I have tried to build a lot of flexibility into the survey design for this project. This is the pilot year for having technicians conduct these surveys. So everything's probably going to be flexible and or squishy. I'll be asking for a lot of feedback on how the logistics worked out for folks. So one of the difficulties for these surveys lies with the disparity between the preferred replication per sample unit of 4 sites and 4 quads and crew size. So for example, all of our crews are comprised of 2 individuals and they share a truck. So it makes it a little bit difficult for them to get 4 surveys done in 4 different locations. And because they move from sample unit to sample unit every single day, they have to get all their surveys done in one night. So this is kind of an example of how that can be done. So our crew members will be splitting up and heading to 2 different survey locations. After listening for bats for 45 minutes, they'll each move to a second location, at least 1 mile from the first, and hopefully, but not necessarily, in a different quad, and then they'll listen for another 45 minutes. This will largely depend on the terrain, the roads, and how many high-quality survey locations there are in a given sample unit. But at least they should be able to conduct 2 to 4 surveys in each sample unit that warrants an audible bat survey. This image shows a kind of ideal situation where there's a nice road going through multiple quads. In this hypothetical situation, the crews would have driven out to that lower site. 1 technician was dropped off. The other drove to that more northern site. They each listened for 45 minutes. The tech that was dropped off walks to their second site. The tech that has the truck drives to their second site. And then after the surveys are completed, the one with the truck goes and picks the other one up, etc. Here's an example of what it might look like for a 4-person crew to complete all of their surveys in one night. Or alternately, a 2-person crew could complete these surveys over 2 nights. When possible, the preference will be for, let's see, for those 45-minute surveys, each to be conducted simultaneously. But again, we all have different numbers in our crews, different numbers of vehicles, what have you. So this is where that flexibility comes in. And of course, some sample units won't have much in the way of good habitat. So in these instances, our field bios and techs are encouraged to make the call to only survey the areas that have cliffs or accessible ridge tops. So in this example, they'd be staying put, but listening for 90 minutes. That being said, I do have 4 survey sites assigned for each sample unit. Those sites will be visible in field maps, and that form will be made available to everyone. Most of you should have received an invitation to join our group via AGOL to access the field maps form. But if you didn't, you can reach out to me and I'll make sure that you have access to that. Let's see. So deciding whether or not a site is appropriate for a survey will be up to each field office. And actually, you'll all be encouraged to select entirely new sites if you know of or see better alternatives. Obviously, what we see when we're going through our steps with GIS is not always exactly what things look like on the ground. So I'll be relying on the folks that are conducting these surveys to do some ground truthing and make adjustments as they go. So you'll notice in these examples that our sites are not distributed among the 4 quadrants. This is because we are focusing so specifically on those potential roost features and accessibility. So the only strict rule for site selection will be to ensure that all sites are at least 1 mile apart. So the field maps form is going to look pretty similar, but a little shorter to our NABat field maps form. So as with the NABat form, the sample unit or GRITS number is going to auto-populate. You'll be putting in your state, the quad, your name, contact info, habitat, the date for your survey, and what time it's going to start, what time it's going to end. For sites that you arrive to before dark, you'll go ahead and attach a site photo. If you're doing 2 locations in one night, obviously you're arriving at the second location in the dark. There's no need to take a photo of that. Most of your detection targets will be cliff tops or ridge tops. There'll be some cliff bottoms and a few water bodies, but again, we're trying to focus on those rocky potential roosting features. So when you first arrive at your survey site, you're going to fill out the initial data sheet and go ahead and click the check mark once you're done with that. And then once you're ready to start marking your observations of bats, you're going to go ahead and tap on the point that you just created, and then you'll be clicking this little chain link symbol that takes you to a separate table for your bat observation. So the first thing you want to do is just make sure that you've clicked on the correct point, and then you'll go ahead and hit add. And then it takes you to this super simple sheet where you're just going to put the species and the time observed and then the number of individuals. For number of individuals with spotted bats, we're going to default to 1. It can be really difficult to know if you've heard more than 1 bat at a time. The only time I want you to put that you've got 2 or more bats if you're very distinctly hearing 1, say, to your left and 1 to your right at exactly the same time. They will fly in circles and it can get a little bit disorienting. And this is not, we're not looking at trying to estimate populations or anything like that with this. We're just trying to get presence absence. That's why we're defaulting to 1. But if you hear more than 1, that would be interesting for us to know. So that's why I'm giving you the option. With pallid bats, you may hear a number of them at the same time, especially if you are very close to a maternity colony. So do your best to kind of estimate. But again, the number of individuals is the least important field on this sheet. As far as comments go, anything you think might be interesting, if you're not super confident in your observation, or if the bat is behaving strangely, or if you can see where it's flying in and out of, That's all information that I'll find super interesting. I personally think the more notes, the better. So don't be shy about it. So once you've submitted a bat observation, you should see a screen that looks like this. And then you can go ahead and tap that little chain link symbol at the bottom to get your next bat observation sheet ready. So that's it for the form. It's pretty simple. If this is something that you would like to participate in, I am asking folks to just let me know which sample units they'll be conducting surveys in. So I have made a web map for you to do that. We'll be sending out a link for that along with the 2 field manuals and other things that have been promised today. But essentially this website, you can go through, use the little edit icon to select a sample unit. And when you do that, it'll just let you put in your agency and your contact info. And that's how I know that someone is signed up for that sample unit. When looking at the map, any sample unit that's filled in gray has already been claimed by someone. So find yourself another one. And this map does label who usually does the NABat surveys for a given sample unit, but you don't need to be restricted in any way. Say there's one that looks really convenient to you that another agency generally does the NABat sampling for, you can go ahead and sign up to do audible bat surveys there. Not every partner has committed to doing these surveys. So just doing them wherever is convenient for you works well for us. And that is going to do it.
Awesome. Thanks, Sarah.
Yeah.
And we did just have a question asking about from Kimberly. Are you saying this is a different group we need to belong to in AGOL? This is not an NABat group. And I had answered saying, you know, like your web map has a sign up that is in addition to our stationary acoustic NABat surveys. So
Yeah, and additionally, the field maps form is in a different group. So that's not in the same group as how you access your NABat data sheet. So you will need to get added to that group in order to access the Audible Bats data sheet. But again, I sent out between Friday afternoon and 8:30 this morning, I sent out a bunch of invitations to join that group. So you just want to check your AGOL notifications. And if you didn't get an invitation, you can reach out to me. I'll drop my email in the chat for that.
okay, great. Any other questions from folks regarding the Audible Bats survey? Again, you can either raise your hand or just unmute yourself or put her in the chat. We accept all forms of questions.
I have a quick question for you then. This is Kim Thompson. So actually, Sarah, I think I spoke with you a while back, and I was curious because one of our regular survey units for NABat wasn't included here, and you explained the reasoning. But after watching your presentation, all this about, cliff faces and that survey unit does have a lot of really good cliffs and cliff faces, and I did check, and we did get pallets at our MissNet site within that survey unit. So is that something, should I reach back out to you and we see about adding it into this Audible survey then?
Yes, absolutely. And yeah, the way that I, selected these sample units was based on GIS layers that showed where supposed cliffs and canyons were. But as we all know, those things are not always 100% accurate. So yeah, and this goes for anyone, if you know of an NABat sample unit that's within either of those species ranges that has good cliff habitat, just like Kim did, reach out to me and I can go ahead and add that sample unit to the project.
Yeah, that sounds great. That great question. Thanks, Kim.
Thank you.
Any other questions for us at this time? If not, you know, if you think of something later, you can just feel free to reach out to one of us. I will also pop my email into the chat. I don't think that I have done that yet. Feel free to reach out to us anytime. I'm also fine with phone calls. We like questions. Even if you're out in the field and wondering, you know, debating between two detector sighting locations and you need help, you know, discerning what the best spot's going to be. I love those types of questions. So, you know, yeah, feel free to call or email, and we can make ourselves available to help. But I guess if no one has any more further questions, then we'll go ahead and wrap this up. Big thank you to Sarah and Patrick for helping present. And yeah, good luck out there, everyone. Like I said, give us a call or shoot us an email as things pop up for you. And yeah, thanks so much, everyone. Take care.